Hello again, everybody. This video is about if you ever had the problem where you're troubleshooting and let's say your voltage is being pulled down or loaded down, as they say in terminology of electronics. Pull down means you have 12 volts. When you measure the sensors, they measure 9 volts all over. So of course, if it's a common bus line, which B plus is, everywhere you go, you'll measure 9 volts. So the difficult part of it is, if you have many sensors, many components, you have to take off component by component by component. You take off the connector, and then you see when the voltage goes back up. So in other words, if you have 12 volts, the whole bus line is connected to this. Everything will be dragged down to 9 volts. So the old school method is to go and take off component by component by component. When the voltage comes back up or normalizes to 12 volts, that's the component which pulled you down. That's fine and dandy. Let's say you have a printed circuit board. You might have 200, 300 components on the B plus line that's shorted. You're going to pull off every single component. Sometimes you have chips, many chips with many pins. Are you going to take off another capacitor, another resistor, another resistor, another capacitor? So 20, 30 components to get to the faulty one. Now, let's say you are, as I did, troubleshooting a PCM when it was shorted. There are many, many components going to B plus, like I just stressed the point. It is tedious, it is time consuming to pull off component by component by component on a printed circuit board. And even in automotive, finding the components and having access to the component to disconnect it sometimes may be difficult. It might be in a very tight spot to disconnect everything. That's one of the biggest problems in automotive, to get access to the part. On the printed circuit board, you have access. Everything is here ready for you. It's a different world in automotive. However, there is a technique in printed circuit boards which I have been using. Let's say there's 12 volts going over here. Actually, the chips will use 5 volts or less, sometimes 3.3 volts. I am not going to go and put from a power supply 12 volts, 9 volts, because I know there's a short somewhere. It's going to be pulled down, and it might take some components with it. So the technique that I have, and I found it to be pretty helpful, instead of putting 5 volts, 3 volts, 2 volts, I'm going to even put less than 1 volt. 1 volt is equal to 100 millivolts, which is actually, 1 volt is equal to 1,000 millivolts. 100 millivolt is equal to 0.1 volt. I'm going to put in 0.1 volt from a power supply. Now you're going to ask yourself, how am I going from 12 volts to 100 millivolts? This will suffice, and this will be sufficient enough to go, if there's a short, to pull it down. I don't want to risk doing damages to the chips. And I don't want to blow a fuse, because what's the point of that? Then I'll have no voltage all over the board. So the technique is to go break the board into quadrants. This will be quadrant number 1. This will be quadrant number 2, quadrant number 3, quadrant number 4, the corners. The middle is where will be my input from the power supply. And what do I mean? In order to understand this, I had to illustrate it. Now, let's say you have 3 components in the middle, as we do over here. We have, if I can show you, these components over here. Those components over here are represented by this on my diagram, on my illustration. I'm going to take a power supply. Like I said, I'm going to put 100 millivolts. I'm going to solder it, solder one end to this part of the resistor, solder the other end to this part of the resistor through jumper wires. So one here, one here. I'm going to attach my positive or negative, doesn't matter, to this resistor. So basically, I'm putting 100 millivolts through this circuit, through this printed circuit board. I can choose this, I can choose this. I just like to to find a component that's a nice thick component that I can solder my jumper wires to. Or I can go, excuse me, from the power supply right to the resistor. Doesn't matter. What's the point of this whole experiment? I don't want to take off 200, 300 components from the printed circuit board, because sometimes you have a motherboard that has many, many, many components. You have connectors. You can't do like that. You can't troubleshoot like that. It is time consuming, and then you're taking off too many components in order to find one short. I'm going to put 100 millivolts, like I said, across here, or across this one, wherever there's a nice thick component that I can solder it to. Now, there are lands, there are traces going from here to this quadrant that I told you. Lands and components and wiring going to this quadrant. Actually, this is quadrant 3, and this is quadrant 2. Same applies over here. Same applies over here. So what we're dealing with is this quadrant, like I said, this quadrant, and this quadrant. Putting the power supply right in the middle. And I'll make a video to illustrate my point. But first, I want to introduce you to this idea, because I've never seen it, but I think it's a worthy technique. If I put 100 millivolts over here, I go with my meter to this quadrant over here, or to this component. Let's say there's another resistor here, or a capacitor, whatever it is. I measure with my meter, and I measure 90 millivolts. That's good. It's not being loaded down. I go to anywhere in this quadrant in the corner, and I measure 90 millivolts, 85 millivolts. You're going to have a small loss through the traces and all that, but insignificant to me. Why? I'm looking for a good loss, a good drop across it. All I need is 100 millivolts. I don't need 3 volts, 5 volts. If the short is there, the short is there. So I go to this component. Let's say this is C1. I measure with my meter 90 millivolts. That's good. I come over here to this corner, 90 millivolts. That's good. Therefore, if I would measure over here on this component or any component, I put 100 millivolts here, and I measure 90 millivolts here, I don't have a loss. Right? I could go across this one and measure it. This quadrant. I divided the board into quadrants. That's why I need this illustration. What about this quadrant? Again, I put 100 millivolts across this fat resistor over here. I go over here to any component and I measure 90 millivolts. Let's say this is R58, whatever. Measure across this with a meter, 190 millivolts. Good. I expect to lose a little. It's okay. I go to the quadrant, to the corner. I measure 85, 90 millivolts. I'm not being loaded down. That's good. Doesn't seem like the short is in this area. Let's go to this. This is the quadrant. Right? We dealt with this quadrant. 100 millivolts, 90 millivolts, 85 millivolts. The short could not be in this area. Therefore, we go to this area over here. 90 millivolts, 90 millivolts. Let's say there's a resistor here, a coil, whatever. We go over here and we measure across here, this small one over here. We don't measure except 90 millivolts. Pretty good. We don't have the loss here. Again, we go over here. Actually, this one, before I make the point. Again, 100 millivolts here. I go over here to this component. Let's say it's a coil. Let's say it's a capacitor. Doesn't interest me. Doesn't interest me. I go over here with both leads of the meter. I measure across it, 90 millivolts. I go to a component here, 90 millivolts. Coming back to this. Let's say I come to this component. There's a resistor, whatever. I find somewhere here and I measure it. 90 millivolts or 85 millivolts is acceptable, whatever. So far, quadrant is good. What am I left with? So far, I didn't find a short. My quadrant over here, 100 millivolts. I go to a capacitor, a coil, a resistor, anything. I measure 30 millivolts. Oh boy, that's not good. I lost 70 millivolts somewhere. And then when I go to another component in this corner, I just lost, it went down to 20 millivolts. That means this, somewhere in this area, it is being loaded down. Now at least, I can get it down to this area instead of the whole board. I got it down to this quadrant. Now, I can start taking things off, maybe 2, 3 components. Boom. When I take this off, the component, let's say this is the faulty one. This is the bad one. I take this one off. Let's say it is R91. R91. I took off R91. I measured it, and it went right back to 90 millivolts. That means I found my short here. So I didn't have to take off 20, 30 sensors, 20, 30. I didn't need to do that. Going to the board itself, this is the quadrant, the third quadrant. Again, I put 100 millivolts here. I went over here and I picked a point. Let's say any resistor or capacitor, and I measured 30 millivolts. Right away I know that's a loss. Somewhere over here, a component is loading it down. And when I go here, or here, or here, I measure 20 millivolts, I know somewhere in this area, there is a loss, or short. I didn't have to go take off so many components, but I got it down to this quadrant. You understand? Instead of going here or here, taking off component by component, at least I got it down to this area, and I pull off the component that I think is faulty because it went down from 100 millivolts to 30 millivolts, 20 millivolts, whatever. Take off 2, 3 components, whatever. It's better than taking off 80 components. And I take them off and it comes back and it normalizes. That's my area. This is the area to concentrate on. It's been a successful technique for me. Again, I haven't seen it done by, I guess, too many people on YouTube. But again, taking sensors off and things like that or whatever is difficult because you have hard wiring. It's much different. However, the concept, if you find a place that you could open up, if you have fuses from ECM and other fuses and it is being loaded down, I take off that fuse, I open the circuit, I take out that fuse to not give any voltage to the ECM. I inject maybe 5 volts or whatever, 5 volts to the sensors, whatever, and I see what's loading it down. I took the ECM, the PCM out of the equation because I opened the fuse from PCM fuse and to the relays to the inputs of the sensors. So you have to know where to break the circuit when you do this experiment in automotive. You have to look at the schematic, study it, and say, let me take out this fuse. Let me take a power supply. Let me put 5 volts to see if the computer is loading it down or the sensors is loading it down. I pick a meter and I measure. If I don't measure anything being loaded down, you can even put 12 volts. I could put 12 volts instead of 5 volts. I could put 12 volts. I opened up the circuit. I took this one out. If everything is normal here, that means the computer just loaded it down. And remember, circuitry in the computer, many chips. I hope this was helpful. Please subscribe to my channel, Automotive Electronic Schematics by Joseph. And my other one, Joe Electronic Schematics for Auto. And you'll see many schematics and diagnosing. Thank you for watching. Please stay tuned for more until I do another video with the actual hands-on on the board to show you. This was an introduction to give you the concept. Thank you very much.